This is the integral from 0 to pi of e to the I theta d theta, but we'll do this with substitution. So let u equal to I theta, and that means then du is equal to I d theta. So notice this is theta, so when theta has the value 0, we have a u being equal to I times 0, which is 0. Now this is pi, so theta is equal to pi. And we have u is equal to I pi. So now we replace here. We're going to have the integral. Going back to here for a second, you got to solve for d theta. So you know that here, that going down this way, du over I is equal to d theta. So d over I, the I goes outside as 1 over I. So you have 1 over I here. And then the limit becomes 0. The upper one is pi I. Then you have e to the u du. And then you can just apply everything you know about the differentiation. So 1 over I. And this is going to be e to the u evaluated between pi I and 0. So continue that. So 1 over I. And this is going to be e to the pi I minus e to the 0. So you're going to have 1 over I and then e to the pi I. So cosine of phi plus I sine of phi minus 1. So 1 over I. Okay, now this part, that's negative 1. This part, that's 0. So 0 and then negative 1 is left over. So it looks just like this. So then you have here 1 over I. Let's see, and times negative 2. But that then becomes negative 2 over I multiplied by I over I because that's 1. We don't want I in the bottom. So you have negative 2I. Now I times I is I squared, which is negative 1. So then you divide. So 2I is the result. Leave a like if it's helpful.